Welcome everyone to EPA's Decentralized Wastewater webcast series. Today's session is titled Career Perspectives in Decentralized Wastewater Management. My name is Zach Lowenstein and I work at EPA headquarters in Washington, D.C. in the Decentralized Wastewater Program as part of the Office of Wastewater Management. The program manages the Decentralized MOU Partnership and our annual homeowner outreach and education program, Septic Smart Week. The MOU Partnership joins EPA and 18 partner organizations together to work collaboratively at the national level to improve decentralized performance and protect the nation's public health and water resources. As part of the MOU Partnership, we are pleased to sponsor this webinar. Before starting, I just want to cover a few important logistical items. You should have the Adobe Connect session running with the cover slide for the webcast series showing on your screen currently. If you have called into this webinar, please mute your phones to limit any feedback. If you are having technical difficulties, please type in the chat box on the lower left-hand corner of your screen and someone from our team will assist you. Speaking of the chat box, you can use this to ask questions at any time during the webinar. We will note your questions and they will be answered at the end of the presentation. The webinar is being recorded and will be posted to our website, which is www.epa.gov/septic, shortly after it airs. Now, before beginning, I'd like to introduce the webinar topic. One of the issues that faces the water sector workforce overall is an aging workforce where the knowledge and skill sets are often difficult to transfer to the next generation of workers. With this webinar, we're attempting to help bridge that gap by having 3 soon-to-retire or partially retired decentralized wastewater career professionals speak about their personal career paths, thoughts on the industry through their decades of work, and thoughts on the future of the industry. The webinar will also explain EPA's role with regard to decentralized systems from the pre-EPA days to the 1997 report to Congress, which emphasized decentralized systems as cost-effective and a long-term option for meeting public health and water quality goals, and through the creation of the Decentralized Program and MOU Partnership. I'd also like to note that the format of this webinar is unique in that each speaker will talk about certain parts of their career, so the speakers will rotate quite a bit throughout the webinar. Now I will introduce the speakers, starting with Mary Clark, who is the project manager at the Vermont Department of Environmental Conservation. She earned her BS in Natural Resource Conservation at the University of Connecticut. Mary started her career with engineering firms, then as a regulator for Vermont, followed by a stint of working as a licensed designer, and then a decade of work with Stone Environmental Incorporated. Mary currently manages the Indirect Discharge Program for Vermont, and she recently served as president of SORA, and has served on the board for NAURA. Dr. Robert Rubin, Emeritus Professor, began his career at North Carolina State University in 1975 after completing his military service. He has worked on a variety of environmental quality issues, provided congressional testimony on wastewater treatment, and served as visiting scientist at the EPA's Office of Wastewater Management to assist with the development of wastewater treatment and management guidelines. Robert has served on many association boards, including WEF, NEHA, NAURA, WRF, and various state agencies. Jim Bell is our third speaker, who's a retired executive vice president of Bio-Microbics. He holds a MS in sanitary engineering and a BS in civil engineering from the University of Missouri. He has worked as a process engineer for Smith & Lovelace Incorporated, designing wastewater treatment systems. In 2008, Jim joined Bio-Microbics as executive vice president to provide process engineering and regulatory expertise. Jim recently served as president of NAURA and serves on various committees for NSF, WEF, and SORA. With that, let's go ahead and get started. Dr. Rubin, I will pass the baton over to you.
Thank you, thank you. I hope everybody can hear me. We talked about our professions, and I was not around in the Minoan age, but to me it's fascinating to look at the history of civilization and this problem that we have had for thousands of years. How do we deal with human waste as populations grow and as urban centers develop? And if you go back and look in history, of course, I was not there, but you can see these pictures, or when you travel through the Middle East or travel through India or Rome, you see all of these facilities that are out there with the same challenge. How do we handle all of this waste from humans? And it continues to be a challenge for all of us. Next slide, please. I like this because this shows that people, this is the original septic tank patent by Marat in France in the mid-1800s. And this shows that people were thinking about how we can handle water carry sewage reasonably safely. This was installed at a parish house in France. But notice the two compartments and the gas outlet baffles, and interesting for 150-year-old technology. They were thinking about how we can deal with these on-site wastewater treatment systems. Jim, I'm going to turn it over for you to kind of bring us into the 70s.
Next slide, please. While we talk about the 1970s, I'd really like to start with 1969. I think that was a pivotal year for the environmental movement. I think 69 had a lot going on. First, we had Neil Armstrong walking on the moon. 1969, I can remember as a teenager being invited by some friends to go to see some rock bands in upstate New York, and I turned it down and thus missed the first Woodstock concert. But I think the pivotal thing in environmental era was the Cuyahoga River, which is near Cleveland, catching on fire. Time magazine did a major spread on that, and it's interesting. It's only the 13th time that river had caught on fire, but it really got national attention. And through the outcry of that, the 1970 Congress created EPA to create a single source environmental control, and thus began our environmental endeavors there. And I remember the cry at that time was to develop swimmable, fishable, and drinkable waterways. The waterways were in such state of pollution that was the main emphasis there. Also in 1970, NSF adopted the National Sanitation Foundation, International, adopted NSF 40, which has stood the test of time over almost 50 years of being the go-to standard for on-site wastewater treatment. Then in 1972, we passed the Clean Water Act, which became the regulation of pollutants to the waters of the United States. Following that, in 1978, well, it actually started earlier in the 70s, the EPA commissioned an on-site wastewater report, kind of known throughout the industry as the University of Wisconsin report on the management of small wastewater flows. This final report was issued in 1978 and is probably still has stood the test time of being the most comprehensive report on on-site wastewater that I know of. Next slide, please. My career kind of started, although I was involved in 1969, really started in 1971. Upon graduating from civil engineering, unlike Bob Rubin and several other people I know, I was at a state in my career where I didn't want to be drafted to join with the forces in Vietnam, so I was able to join the National Guard unit prior to graduating. So right after graduating, I left for my basic training episode. Of course, finishing the basic training and all that involved with that and spending a few weeks at home trying to decide what to do, I did what any young man would do, and I went to visit my girlfriend, who would then later become my wife, at the first day of college. And after walking her to class, I was walking back to try to figure out what to do the rest of the day, ran into a friend of mine I'd known from civil engineering school, and he informed me that they had just formed this group called EPA, and they were giving out free scholarships to get graduate degrees in environmental engineering, and thus began my career in environmental engineering, because by the time I had met my wife that evening, I was already enrolled in college and got one of the last grant programs from EPA to get my master's degree. Following completion of that, I was hired by a company in Kansas City called Smith & Lovelace, which is a manufacturer of pump stations and wastewater treatment systems, as a research engineer. So not only in '73 did I graduate from college, got my first job, I also got married and then proceeded with my career. Next slide, please. One of the things that I think is important to know about that University of Wisconsin study I talked about, the management of small wastewater flows, is the number of professionals that were involved in that project that are leaders in our industry. That report had over 50 professionals from the University of Wisconsin that were involved in that program. And from that, we got people like the EPA project officer at the time was Jim Crissell, who's well known in the on-site industry. Jerry Tyler, who was from the soils department, he was one of 19 soil scientists that were involved in that project. Dr. Otis, Dr. Dick Otis, and Dr. Bob Segrist were part of the engineering department that actually 2 of the 13 members from the engineering department that were involved in that. And also Jim Converse from the Ag Engineering Group was involved in that project. Jim went on to lead the Ag Engineering program in the on-site wastewater field. So we were very lucky to have EPA sponsor that research in the 1970s, not only for the benefits that came out of that research, but the professionals that came out of the group that worked on that research. And with this, I'm going to turn it over to Bob in the next slide.
Thank you, Jim. My career started in the mid-'70s when I got out of the service, and I am forever grateful to Steve Steinbeck and Dr. Bobby Carlisle for developing our program here in North Carolina. We were one of the first states in the country to look at developing or to develop on-site sewage rules that were based on comprehensive site and soil assessments, no longer on just a perk test. We started looking at soil evaluations and site evaluations, and I began my career working with Bob Carlisle and Steve Steinbeck, going out and training the local environmental health staff in all of the counties here in North Carolina. Our efforts were kind of amplified, and I think this is something you're going to hear over and over in our conversation. Our efforts were amplified by a grant that we received. Grant is the operative word from EPA Region 4 to the Triangle J Council of Governments to assess a variety of on-site wastewater treatment system applications that would function here in the Research Triangle area. The Research Triangle area was starting to grow rapidly. We have some problem soils in the area. And EPA was very interested in facilitating and encouraging research in alternative technologies. Those were specifically mentioned in the Clean Water Act, innovative and alternative technologies as a way of dealing with challenging conditions. We did a lot of work on low pressure pipe systems, pressurized sewage dispersal systems, mound systems, media filters, sand filters. We had a demonstration site here in North Carolina where we took sewage from the city of Durham and treated it on a variety of sites. And this information didn't just sit idly by. We did publish that information in the first couple of American Society of Agricultural Engineers and the NSF on-site wastewater conferences that served, I think, as the foundation for the growth of this industry or these technologies. So they were very, very exciting times. We worked not just in North Carolina, but across the Southeast in developing some of these technologies. Next slide, please.
Is that better? That's loud.
Can you make sure to mute your lines, please, if you're not speaking?
Next slide. Hello. Did something just happen to my phone?
No, I can hear you. The next slide.
Okay, would you go to the next slide?
Hey, Bob, can you see the slides switching?
I cannot. I see the 1970s Bob Rubin slide. I do not see the slide that follows that, slide number 9, showing a soil profile and some other things. My computer may be stuck. I'm not sure.
Okay, we may be having issues with Adobe Connect, but we do see the soil.
Okay, I got it.
Okay.
So we started looking at improvements in sites and soil evaluations. We looked comprehensively or in depth, that's my humor, everybody, at soil profiles and how we can optimize treatment. We looked at different types of permeability testing, field testing that could be done, and we looked at the importance of landscape and landscape position. So our assessments, our evaluations were very, very, I think, comprehensive. Next slide, please. And I want to emphasize the evaluation was looking at the soil dispersal component, not the soil disposal component. A soil is a treatment medium, and soil provides outstanding treatment for a variety of different societal or human byproducts. We looked at the importance of soil as a treatment mechanism when we had monitoring and groundwater monitoring, surface water monitoring. We continued to develop our rules through the 70s and early 80s, and we incorporated into our rule better technique for doing site and soil assessments. And I think those are all extremely important as we look at our on-site wastewater industry. Mary, I'm going to turn it back over to you.
Okay, great. Thank you. I wanted to first thank everyone for inviting me to be a part of this webinar. I'm deeply honored to be in the presence of two of our great professionals, Jim and Bob. I think we've all known each other for at least 25 years, and while our paths have crossed, we'll be offering 3 different perspectives on our industry. I wanted to thank the EPA Decentralized team and their contractors, and the MOU partners for all of the priority work identified in the strategic plan and what continues to be implemented from that plan. Having 18 nonprofit organizations focused on decentralized wastewater is a wonderful thing, so it's much appreciated by the industry people. So I graduated from UConn so long ago, I almost could have made the women's basketball team. Yeah, it was early on. It was the first year for a new major in natural resources conservation. So almost anything that I wanted to take having to do with agricultural sciences or biology, math, all kind of came under that major. It was a nice broad major. And as with most other graduates, I found some interesting part-time work before moving to Vermont and being hired by a consulting engineer. The engineering officer was a one-man engineer, and he had 2 part-time people, so we got to do everything in the office, which was really cool because you got to do the field work, the topographic surveys, the perk tests, the backhoe test pits, as well as learning how to draw up the plans and the specifications and the whole application process. We did civil and sanitary work, so it was a wide variety, but because Vermont is so dependent on on-site wastewater for treatment systems, many of those projects had on-site systems. And I just want to point out this picture here is probably the smallest scale maple sap collection system that you'll ever see. It's near our home in Vermont. So next slide, please. Okay, so 70s in Vermont, and really across the country, the health department regulations, I think were the first ones to be identified for this industry, because really they were worried about public health concerns. And the water quality issues came later, although, they're definitely tied, like as you can see in this picture, where you have, small camps on very small lots, close together, where who knows what the soils are like and what kind of a septic system was located there. So really in Vermont, these regulations were administered at the local level. So out of the 241 towns in Vermont, most are under population 2,000, and really only a handful were large enough to have staff trained to review and approve wastewater system designs. That meant there was a wide range in quality of the work and the review and where systems were actually constructed. Plus, we have really terrible soils in Vermont for conventional leach fields due to the glacier. We have glacial tills, we have exposed or shallow bedrock, and then we have a mixture of sands and gravels and silt all kind of mixed together. So it does mean that we have a fluctuating water table in the soils that back in the 70s, if you dug a hole in August and there was no water in it, then that's what you said. We didn't really have the tools to be able to determine where that water table was unless we dug the hole in the spring. So next.
Well, thank you. We continue our little walk down memory lane. There were some really monumental things that happened in the late 70s, early, mid-80s. I think one of the first was EPA published their on-site wastewater treatment and disposal manual, and there were a lot of people from a lot of universities and private consulting firms that reviewed and helped edit that document. The construction grant program kind of began to evolve, and there were a couple of projects, not a whole lot, but a couple of projects that dealt with on-site wastewater treatment funding, both through the U.S. EPA grant program as well as through the U.S. Department of Agriculture Rural Utilities programs. The other thing that started to happen in the late 70s throughout the 80s was a bunch of new technologies began to develop. The aerobic treatment units, the home on-site wastewater treatment systems. And these systems used the NSF Standard 40 to document their performance. And also, and thanks to the Small Flows Clearinghouse, we started to see a lot of on-site demonstration projects develop around the country, and the Small Flows Clearinghouse was really influential in promoting what on-site technologies can do. Late in the 70s, we had the It's Your Choice guidebook for elected and appointed officials to provide them some information on performance of on-site technologies and monitoring and management requirements for on-site technologies, and cost. Also in the 80s, we received another grant here in North Carolina. This was up in the mountains to look at on-site wastewater technologies for our mountain region of the state. And again, we looked at a variety of treatment and dispersal options there. We also had some really groundbreaking work done by Mark Softy and Craig Cogger, looking at the movement of virus particles in shallow water table soils. And our late 1980s, we did a lot of work in the coastal plain or Craven County on-site wastewater projects, and we put the first pre-treatment and drip irrigation system in North Carolina at a highway rest stop in eastern North Carolina. Very advanced treatment and very shallow placement. So we started using these technologies very aggressively throughout the state. Again, I want to emphasize next slide, please. I want to emphasize the importance of publication. Information doesn't do anybody any good if it doesn't get published and doesn't get out there so that we can use it. The American Society of Ag Engineers continued to develop their on-site wastewater program manuals. NSF for a number of years reported on their NSF conference. And again, you can see I worked with, I was co-chair of the ASAE on-site wastewater symposium that we did in the late 1980s, early 1990s. And I'm going to turn this back over now to you, Jim.
You know, in the 1980s, you have to reflect on what the Clean Water Act did. The Clean Water Act basically was focusing on the waters of the United States. So the construction grants program was primarily providing funding for point source pollution. So we were spending our time working for a larger company designing pump stations and wastewater treatment systems for point discharges at that time. We did, in the 70s, participate in the development of a treatment technology, which we now sell today, that was used in the University of Wisconsin study. But unfortunately, the market wasn't prepared yet for advanced treatment systems with nitrogen reduction, that type of things, in the 80s, because all the focus was on the waters. It was interesting that we took that treatment technology to a company in St. Louis that was building marine barges at the time to sell on the tugboats going up and down the intercoastal waterways, because they did have to meet the treatment levels dispersing of wastewater into the waters of the United States. So that's where the first kind of came along. So I continued my development in the 1980s as a process engineer, got my PE license, and then ironically I participated in my first standards writing with the American Society of Civil Engineers, which taught me how to handle the development of standards later in my career. And I'll turn it over to Mary.
Mary, are you on mute?
Yes, I am. Thank you. Okay, so I continued working for consulting engineers for 7 years total. That work was really so long ago that it was before AutoCAD came into the offices, so everything was done with pen and ink and on Mylar, which I love to do. Anyway, so after that we went to, stay on the first slide, thank you, and next slide, back. So I stayed with the state of Vermont. I was assistant regional engineer from 83 to 90, and so was actually going out onto sites and reviewing soils and approving or disapproving them to go ahead with the design and the application. And at that time, the regulations were so difficult that many sites did not make it. I remember one farm, 400-acre farm in Franklin, Vermont, that we spent the whole day digging backhoe test pits everywhere, and we could not even tell him he could subdivide one lot for his children for their house, which was pretty heartbreaking and stressful to have so much bad news for people. And we really didn't, at that time, have any other options like with advanced treatment in order to give them some hope for something different. So what happened was that the Vermont regulations covered new subdivisions that were less than 10 acres in size and commercial properties, but pre-existing homes and homes that were on over 10 acres did not need a state permit. And whether the town had permits or not, it was all over the place. A lot of them did not require any permitting at all. So you see this picture here where you have these fairly long, narrow lots that were created, 10.1 acres in size, to meet that standard, but then they go back several thousand feet. And the idea was they thought that the house was going to go in the middle of a lot. It's 10 acres. Nobody had to worry about it. Well, everybody built their house along the road. So really you lost the use of that, the rest of that 10-acre lot. It was taken out of either agriculture or forestry land use. So it really did a disservice for our land use planning at the time. So I wanted to mention that Jim had brought up about the trainers, the national trainers, and that really was the first time in the early 80s is when they came to Vermont and trained our designers and consultants. Jim Converse was there and Dick Otis. They did a soil laboratory to show water movement through different types of textures, and really then Jim Kreisel, was training on the EPA's Purple Book. Those were really wonderful training opportunities, and I have to say that the pressure distribution calculations that came out of them, because that was when they were also promoting the design for a Wisconsin mound, which was a pressure distribution mound, and which was adopted by the state of Vermont. So it was very wonderful to have that kind of training come to us. So next slide, please.
Okay, this is Jim again. Oh, I'm sorry, Mary, it's your turn.
Okay. Yep, so I'll do the 90s, and Jim will jump in with the 2000s, right? So, yeah, there were a lot of technologies, advanced treatment technologies that were looking at how to reduce nitrogen. At that time, there wasn't as much really focus on phosphorus. They were looking at more of the coastal communities. NSF was rewriting their rules, and Jim can talk to that a little bit more probably. And the Massachusetts, what they call their Title V system, the regulation came into effect, plus they were requiring some nitrogen reduction on systems that were close to the coastal waters. And the Title V system really was a big boost, I think, to our industry. It was difficult for towns because it required that there would be some kind of an inspection, and if you could not meet the inspection, then you had to upgrade your system to the best possible standard. So at the same time that they put that requirement in place, they added community on-site loan programs and grant programs in order to help support people when they wanted to sell their house or improve their system. Those, okay, I think I have, do I have I have my own 90s slide later? Is that correct?
I wanted to jump in here, Mary, and mention that I think a pivotal thing in the 1990s was the advancement of technologies for nutrient reduction, but I think a more pivotal thing that changed our industry was this 1996 report by EPA on watershed approach framework. What that did is we spent 20 years in point discharge in providing treatment to improve the streams, and it made a tremendous impact, but it didn't quite take us all the way. And this document in 1996 was EPA finally saying, hey, maybe instead of point discharge, we also need to look at the watersheds. And looking at the watersheds brought the on-site industry under the not the control of, but in the sights of the EPA in regards to their watershed management. And it was, I think, the beginning of the framework of moving away from not only looking at point discharges, but looking at non-point discharges. And I'll turn it over to Bob for the next slide.
Thank you. And I wanted to emphasize also in the late 90s, there was a Congressional Research Service report that came out looking at on-site technologies and why there was a general lack of adoption of some of the on-site technologies, and that report went to Congress, and Congress inquired with EPA, and EPA sent back to Congress the response to Congress on the use of on-site technologies. And again, Jim mentioned the watershed approach, and this document that went from the agency back to Congress really set the stage for kind of a resurgence of interest in these on-site technologies. I was extremely lucky, and I'll never forget the time I spent with EPA working with them as a visiting scientist with Joyce Hudson and Steve Hoagie and Bob Bastian. Really, really wonderful, wonderful people, and absolutely, completely dedicated to protection of the environment and protection of public health. So in the 2000s, again, we had reports, the American Society of Ag Engineers, or Agricultural and Biological Engineers, continues to publish symposia. EPA updated the design manual, and we had voluntary guidelines, and Jim mentioned nutrient reduction. Now NSF is adopting nutrient standards. And then in 2000, the late 2000s, or 2007, 2008, the biggest hit to this industry was our housing crunch, or housing market crunch. Somebody would go to the next slide, please. You can see some of the documents that were developed, prepared by EPA. A wealth of information, and it's still available on the EPA website. But through all of this, we re-emphasize the need for training, and not just training of site evaluators, but training of everybody involved in the industry. And we also saw more and more training introduced by, or introduced at the state level by state state associations, state water quality associations, state state associations. Okay, yeah. Next slide, please. Also, about the same time, we started looking more and more at water reuse, and NSF developed the EPA was working on water reuse and water reuse standards and water reuse guidelines, but those were for municipal systems. We started looking aggressively at, well, how can we apply reuse to the local, to the on-site level? And NSF came up with the 350 standard. It's the effluent criteria for on-site reuse. And this was intended as a tool for communities to use where there were no on-site water reuse standards. We have the different classifications of water. These are good for systems up to 1,500 gallons a day, and beyond that, some special engineering is probably going to be required, but these are good standards for on-site reuse. Next example, please, or next slide, please. We put that to work at Wilkerson Park in Raleigh, North Carolina. This is a county park. It was land that was donated, given to the city of Raleigh by Annie B. Wilkerson, the former health director for Wake County. And in her will, she donated this 248-acre parcel of land on the water supply for the city of Raleigh. And she said, I want in my will to make sure that whatever we do there is going to be low impact development, and I want it to demonstrate the best available technology we can do to promote wastewater management. So we came up with this on-site reuse system. You can see our state requirements for BOD and TSS, coliform and turbidity on this little chart. That's a picture of the park there. And you can see our monitoring results. We have many, many years of monitoring results now. Our BODs and TSS numbers are below detection. Our total nitrogen is 4 milligrams per liter. Coliform is below detection. And you can see our turbidity number, which is an indicator of the performance of these advanced treatment units, is way below the required treatment standard. So we can do a lot with treatment and reuse and management of these systems at the local level. Next slide, please. And I think it's important to mention that there are some large municipalities across the country, San Francisco, New York, Seattle, Washington, where they're looking at developing on-site water reuse to augment or supplant potable water systems. This is a picture of the Solaire building in Battery Park in New York. They put a decentralized wastewater treatment system in the bottom of that building, and they recycle water through that facility for toilet flushing. The grounds around the building are irrigated with reclaimed water. The system is permitted by the Department of Buildings for the city of New York, but it shows, if you look at the values here, the numbers here, you can see tremendous reduction in water use in that building, and a 48% reduction in water consumption because of the reuse, and a 50% reduction, over 50% reduction in the wastewater discharge from that building. And we see the same kinds of things in other areas where they're doing on-site reuse in urban areas. And I do think that's a major role for the on-site industry in the future. And I do want to give credit to Natural Systems Utilities for the work that they're doing. I want to give credit to the San Francisco Public Utility Department for the work that they're doing looking at on-site reuse in these urban areas. And I'm going to turn this back over now to Jim.
Professionally in the 1990s and into 2000, I was basically doing kind of the same thing, but I kind of split off into a role, and it all started, I think, in 1993 when a good friend of mine, Stephen Berkowitz, and myself joined the NSF Joint Committee to develop standards for NSF. And through those years, Stephen and I and Bob Ashton, several other people on this call have worked together to develop a lot of standards at NSF where we expanded into nutrient reduction, water reuse, just to name a few. In 1996, we at Smith & Lovis had kind of decided that in order to be effective in the on-site wastewater market, we had to split off. And that time we formed Bio-Microbics as an independent company to market in the on-site wastewater industry. And so I was actively involved in that, although I was still employed at Smith & Lovis. And then in 2008, I finally moved over to Bio-Microbics as a full-time employee. So while it was around several years before I actually moved over, I was actively involved mainly through NSF and through other aspects of that. And we'll take it to the next slide, and I'll turn it over to Mary.
Okay, thank you, Jim. So in the 90s, I had been self-employed for a little while, designing small-scale on-site systems, and but most of the time from 97 to 2007, I worked as a project manager for Stone Environmental. And Stone worked all over the country doing community on-site wastewater management plans. They might have included a research element to them, like they did in Nags Head and Malibu, where we were doing studies of groundwater impacts and trying to track plumes of septage in the groundwater. And actually, in Malibu's case, we started modeling them to see both how much the constituents were in there, and then how long it might take for you to get them out to a good enough level once you start applying treatment to it, which ended up being many years that it was going to take for that to improve. Massachusetts, that Title V that I mentioned earlier, so they were doing a lot of community on-site wastewater management plans, and Stone did probably, 10 or 12 of them for different towns, and that would include GIS mapping. GIS was starting to come into its own as far as being able to be a good both a data and a visual projection of what a community was like, and overlay things like the parcel boundaries, the impervious surfaces, and the soils and topography in order to get a good environmental constraint view of a community. We also developed databases for them so that they could start tracking and inventorying their systems. Believe it or not, many jurisdictions only had paper copies of files and nothing beyond that. There were some WRF research projects that Stone Environmental and I was involved with, including a big one on the barriers to using decentralized solutions. And I'm actually going to be talking about that, updating that information, where are we at today compared to then, on the recommendations that came out of that study. So it's not, and actually EPA decentralized team is looking at that study as well, and looking at what still they may be able to do to implement things. We did a Warren EPA demonstration project, which was the first decentralized wastewater system for the state of Vermont, and started with getting a bunch of grant money, but still the town had already rejected a sewer solution, so they weren't too excited about it at first, but then there was a flood that came by and exposed septic tanks and leach fields right next to the river, so they got re-energized to come back in and take another look at their situation. And we were able to construct a large 30,000 gallon a day community wastewater system, a wastewater system that was using innovative technologies and dispersal technologies for the elementary school that had an older system that was just inches from surfacing and failing, and actually found out later was polluting their drinking water well. So getting it moved away from that and into a better treatment really helped improve things on the water side. And then about 2007 is when I took a position with an on-site wastewater treatment equipment manufacturer, and ended up working for manufacturers, two different manufacturers over a 5-year period. Obviously that was when the economic downturn happened, bad timing on my part, so it didn't work out so well, but I sure did learn a lot from looking at that perspective of our industry. Okay, next slide, please. So the 2010s to the present. On-site systems are here to stay. I think everybody understands that now. What is it? I think nationally it's about 25 to 30% of our built environment is using decentralized systems, and they will in the future. In a place like Vermont, we're not going to have direct discharge systems. They're not going to add any more. So really, we're very dependent on the decentralized system, and trying to come up with ways to make small community systems affordable for the owners. There's the new reuse standard by NSF. Again, they're leaders for us for setting standards for this equipment that we're getting. Now we're looking at, that there's really more than, it's not just engineering anymore. There's science, there's soil scientists, there's environmental scientists, there's surface water and groundwater people that are all, interested and involved with looking at how on-site systems can be impacting the environment and public health. The data sharing initiatives like the Chesapeake Bay watershed model, where they've been working with multiple states and developing a way to share and collect the same data from the different states, but be able to have it into one model. There's also the EPA Nitrogen Sensor Challenge that is going on right now, and that's going to be identifying some new monitoring tools that would be able to do real-time monitoring. Performance-based rules are definitely, a lot of the regulations are sliding in that direction, where before they were more prescriptive, but now it's more that sometimes you can get a regulation that will say, well, you have to meet this standard, how are you going to get there? And on the capacity building, I would say that, again, we're talking about very small communities with very small town staff abilities. So they may be able to have a town administrator that would have some time to help with managing a small decentralized system, or they may need to try to find like a more regional approach to it, where they and other towns could share the same entity. So that's where I think we still need a lot of focus in the future. So, Bob is the next slide. Thank you.
Okay. I sound like Buzz Lightyear 2000 to infinity and beyond, I guess. There's a lot of work that's been done. Again, a lot of publications. The WEF publication on water resource recovery facilities has a section now on on-site wastewater treatment. Mike Hines and John Buchanan and I spent a little bit of time working with them on that. We spent a little bit of time working with LEF on the Natural Systems Manual, and again, that's an attempt to develop material information that designers, that regulatory agency people can use to promote the use of these low-energy wastewater treatment technologies, some of them with the ability to recover energy and with nutrients. I'm also looking at what I call behavioral economics. Why do people make the decisions they make? How do people make the decisions they make? What influences decision makers? There's a wonderful gentleman at Duke University, Dan Ariely. If you haven't read any of his information on behavioral economics and why people make the decisions they make, it is fascinating. I've had some very interesting conversations with Dan. I continue to examine laws and rules and codes and those kinds of things that influence what we do as practitioners, and how our laws and rules and codes influence everybody in the profession. I'd like to go back, if I may, just to pick up on some of the things that Mary said that I think are absolutely, Mary and Jim said. We do have the EPA Water Infrastructure Finance Center. They have put out publication and guidance on the use of on-site technologies for a variety of non-point source improvement efforts, and I think it's important that everybody look at those. NOWRA continues to look at influencing congressional decisions on on-site technologies. Our rules, our performance-based rules are growing. So it's a really exciting time to be in the field, and I think the one thing I want to say about 2000 and beyond is it's a team approach, that it's going to be people from the regulatory side, the environmental side, the manufacturing side, the installer side, that really implement the kinds of long-term and sustainable infrastructure that I think we will need, that I believe we will need to promote this industry through the future. And with that, I think I turn this back to Mary. Is that correct?
No, it comes to me. Jim. This is Jim.
Oh, sorry.
In 2010 and beyond, I kind of look at my role as changing from, not only working with an individual manufacturer, but also expanding out into the industry through my involvement with NOWRA, SOAR, and NSF. I think I've got a broad perspective of what's been going on in the industry. I'm particularly proud of NOWRA's accomplishments over the past few years, like Bob had mentioning in the lobbying effort, where we're, I think, changing the landscape of the on-site industry, and also through NOWRA's participation in online learning, so that we're trying to expand the educational opportunities to kind of match the needs of the millennials that are not only looking for face-to-face, but are looking for the online content, and that I think we have provided. I am indicating that in 2019, I have officially retired from full-time employment at Bio-Microbics to part-time employment at Bio-Microbics, where I'm acting more as a consultant for Bio-Microbics. But the one thing I would like to point out is I am still full-time with NOWRA in the advancement of what NOWRA is trying to do, and I kind of am looking at my future as following the Bob Rubin model of retirement. So I think we'll be around a little bit longer so we can work together on in the future and working on all these major issues. And I'll turn it over to Mary.
Yeah, I think we're all going to follow Bob Rubin's model and just kind of step our way out of out of retirement here. Looking forward to that myself. So in the 2010s, I started working for the state of Vermont, and I feel like, yes, I worked for the state back in the 80s, and now I'm coming back, and I do feel like I came here to give back a little bit more of the experience that I learned from all the other work that I was doing in other states. And so I started being the person that was overseeing the innovative alternative treatment technology systems and getting their reviews and approvals through me, which was such an honor since, that was something I feel like the Warren Project helped to push into the Vermont regulations. I also did some staff hydrogeology reviews and managed their licensed designer program, which we decided to shift over to the Secretary of State's office as a licensing program that they manage, which makes a lot of sense, I think, for our industry to go that route. So currently I'm working with the Vermont Indirect Discharge Program. Indirect discharge systems are ones that are 6,500 gallons a day or larger that are on-site systems, sewage systems, and then we also permit the land application of non-sewage wastewater that may be like a food process wastewater from a creamery or brewery and different places that might have nutrient capabilities that would be useful for land application. And then we also manage the UIC program, which handles more of the industrial type wastewater discharges that are also not domestic. So you really have to look at what the constituents are and whether you'd even want to allow them to discharge into the soils. During the time here with the state, I helped to bring in the ideas about high-strength wastewater and how it's really not the same as a single-family residence type of wastewater, but it could be that most of the convenience stores and the donut shops and coffee shops all produce this kind of wastewater, which does require either some kind of pretreatment or vastly larger leach field in order to handle that strength waste. The smaller scale rules just went through a big revision and approval process, so they just got changed. And there is a barrier between the two sets of rules with the indirect discharge and what I call the WW rules. And that is because, there's different standards applied to both, so it's a big barrier, a big jump between the two. And so program manager for the WW rules and our staff have been working to try to kind of figure out the best ways to smooth out that barrier so that community systems can be more easily permitted and used. I've been involved with SORA, which is the State On-Site Regulator Association. So it's all the different regulators at the state level. I was president in 2018. I'm currently past president. This group is a wonderful group and a great way for regulators to interact with each other to try to figure out, new policies or policy or regulation changes and things like that. It also has the captains of industry connection with it. So we're also looking at ways to communicate with the regulated community in order to better, build stronger regulations that can be supported. So here at DEC, we've also, one of my passions and dreams has been to solve the small unsewered villages with some kind of a wastewater infrastructure project. And it's a very difficult thing to do. And our department now realizes that, and they have applied for and won a grant for a project where we're going to be focusing on 3 different villages, 2 towns, and try to see if we can identify and solve the barriers for them moving a project to construction. And the exciting thing to me is that this is the first time I've seen support all the way from our department through the Agency of Natural Resources right up to the governor's office in trying to crack this nut. So, so more to come on that, hopefully. And the last thing that I've been working on during the 2010s and beyond is one that I've been invited by Bob Rubin had recommended me to join the ANSI U.S. tag team for this an ISO standard that they're trying to develop for fecal sludge treatment units that would be used in places where there are no wastewater treatment capacities for billions of people around the globe. And it's related to the Bill and Melinda Gates Foundation to try to bring them a safer wastewater treatment that would be able to be offline, even be able to create its own energy and then hopefully produce something that would be a good fertilizer or different kinds of byproducts out of it. So next. Yeah, so where do we go in the 2020s and beyond? And we're all going to talk off of this slide. I'm going to start. Yeah, to me, the One Water approach, is coming. The city of Burlington here has an integrated water initiative going on right now where they want to look at their municipal sewer system, their combined sewer overflow, and their stormwater, and how best to get the best bang for your buck by doing improvements and prioritizing them that way. So, that's the kind of approach I think that will really help communities in the future to consider. I do think there needs to be more research. I would think mostly on the soils side and the soils acceptance and treatment part of it, not just the nutrient part of it, but I know there have been some early studies now on contaminants of emerging concern. That's not going to go away. It's going to get even, more and more of a concern. So I think, having more research funding available for that. The other thing that research funding does is it helps a university provide the engineering curriculums and degrees that we're looking for. So they kind of go together. You need to be able to give them money to do projects, and then to be able, that will help support their student population. So I guess the last thing I just wanted to say was that we need to expand our world from decentralized, and the MOU Partners is a good model for that. But I'm thinking more on like when we're doing a small community project in a small village. I was at a meeting in the town of Westford just this week, and how to make that funding work. Well, if we know that the highway department is going to be tearing up the road in 2 years, then maybe we can tag along with them in order to help pay for that part of the project. And if historic preservation, there's money for building renovation and smart technologies, and maybe even, that could help connect their sewer connection. These are, this is where I think if we expand on who we're talking to about the funding possibilities, we'll be able to make this affordable so that people can actually build them. Thank you. And Jim?
Okay, Bob, you can go. I'll go last.
Oh, okay. Well, I'm not the least bit shy about talking. I just wish I had something important to say. and I agree with Mary that one water is the approach we need to be looking at. It makes no difference if the source is an on-site wastewater treatment system or a municipal system or an industrial system or stormwater. If we're going to look at water as infrastructure, we have to look at it as one water, because it all ends up in the same place. We will have to do more research. And again, I agree with Mary that part of that is looking at soil absorption systems. Part of that is looking at the capacity of soils to assimilate nutrients and organic material and some of these chemicals of emerging concern. The other, I think, thing that we're going to have to look at is to assure that there are trained, capable, competent service providers out there who can manage these technologies through time. A critical element of infrastructure is that you have people that can do the work. Well, I look at what we do here in North Carolina with our on-site wastewater conference and our North Carolina Septic Tank Association conference. We have thousands of people that go to these meetings. I just left the TAWA conference last week, had 1,000 people at their conference dealing with on-site wastewater management. We have the opportunity to train and certify people to do this work and to do this work well. And I think an important part of that is going to be finance and looking at municipal type models for these distributed systems. How are we going to make sure that they are sustained through time? There are costs, there are capital expense costs and operational expense costs that are going to have to be maintained at the local level by the local community. How can we go about doing that? Those are all things that are going to require research. And then the last thing, in my opinion, is this water reuse. We all know where this water comes from. And when you start talking to people about water reuse, their immediate action or reaction is, yuck, I know where that water came from. Please remember that we have been recycling water through the water cycle for a couple million years. The amount of water that we have in the system has stayed about the same. Water has been recycled for generations, for millennia, and we're enhancing those activities. I know it is getting late. Those are some of the things I wanted to highlight as we look at the 2020s and beyond. It is infrastructure that we're managing. Please remember that. Jim?
The one thing I want to pass on for the future generations is really that water needs to become a commodity, not something we're trying to dispose of. And as a commodity, we need to look at its value. Its value, I think, is available to us through water reuse. And when we address water reuse, I think we have to look at that a little bit differently. I think from a large-scale perspective, does it make sense to take wastewater and pump it for miles and miles to a wastewater treatment plant, treat it, and then pump it for miles and miles back to the home? I think we need to look at more direct water reuse and also more community or not community, maybe subdivision water reuse. That's something we need to look at. The second thing is I think we need to look at, like Bob said, the yuck factor. We are going to be converting wastewater into drinking water. And Bob Bash and I have talked about this several times, is that in doing this, are we measuring all the parameters we need to be measuring in that conversion of wastewater to water? Are there other constituents that we need to be measuring to determine the proper treatment going from wastewater to drinking water other than those typically used and when we look at effluent quality and we look at influent quality for drinking water? Those are parameters we need to look at. And finally, I'd like to point out, these are 3 people on this call that are all leaving this industry. We may be involved in it a little bit longer, but we're going to have to look for the next generation of millennials that are coming on to replace us. Where are they going to come from? What are we going to do to advance their careers? How are we going to be around to mentor them? And this is something that I think EPA is looking at through listening sessions at NAURA. There'll be another listening session on development of personnel, development of the career path for these people in the future prior to, I believe, the NEHA conference, July 9th, I think. But that's something we need to be thinking about. And with that, I thank you all for listening in to us, and I turn it back over to Zach.
I think we actually have one more slide.
Oh, I'm sorry, Zach.
That's okay.
That's okay.
So Bob,
one of the things, yeah, can you hear me?
Yeah.
Can you hear me? Okay. One of the things we would like to emphasize is that there's roles for a variety of professionals. There's no one person that can do everything. So what are some of the criteria we're going to need to establish to assure that the systems function properly in accordance with community needs and state mandates? What and those are going to be different in every receiving environment. So we need flexibility in how we look at the program. Are we protecting public health? Are we protecting environmental quality? Those are the two primary questions. Next question, I think, is, are we protecting the homeowner investment? Most of us look at our home as the most critical investment we will ever make. Are we protecting that? And are we protecting the investment in our community? I'm sure everybody on this call knows of communities in your area where there's a history of failing on-site wastewater or malfunctioning on-site wastewater treatment systems. We do not believe that we can leave a legacy of malfunctioning systems. And we've got to establish criteria that allow us to protect all of those elements of that infrastructure, the public health, the environmental quality, the homeowner investment, and the community investment. How do we review our criteria periodically? We are in the process in North Carolina of reviewing every single one of our environmental laws and rules, and it is an onerous process. And it's something that has to be done at every level periodically. I'm not saying it has to be done every 5 years or every 10 years, but how do we make sure that our laws and rules respond to improved scientific knowledge, knowledge of risk management, knowledge of disease transmission, knowledge of chemical exposures? We've got to establish those levels of review. How do we as professionals advise decision makers in our states and decision makers at the federal level when we need additional laws and rules? And again, how do we, as professionals, assure the sustainability of our programs? I have been honored to be part of this journey, and I'm really glad to see that we have some new professors coming on, or new associate or assistant professors coming on at local colleges and universities. It's the young people, it's the succession planning that assures the sustainability. And I don't care if you're at a local health department or in a state regulatory agency. I don't care if you're an installer or a septic tank pumper. It's your succession plan that assures we have sustainability in this program. And I'm also pleased to see that EPA continues to look at on-site systems, on-lot systems, or decentralized systems as a part of the water infrastructure. So there are roles for all professionals, and I think the way to deal with that is to get involved at your state level, to get involved in national programs like NAURA or WEF, to get involved in research efforts like they do through Water Environment Research Foundation, except it's no longer called Water Environment Research, it's Water Environment and Reuse Foundation. So there are continuing, ongoing roles for everybody. And I think I think the last slide is the one I like the best.
All right. I just want to thank our three speakers, Mary, Jim, and Bob, for that very informative and engaging presentation. You know, what you've all accomplished is very impressive. We have a few questions in the chat box, so I'll just read them off, and I'll let our speakers answer them. I think all of them none of them are specific to any speaker, so any of the three of you can answer, or you can all answer, you know, in succession. So I'll start off. We have the first question from Don. His question is for the three of you. What advice do you have for EPA to carve out a path for the future? For example, what particular types of guidance documents should EPA develop or update?
Bob, I think you'd best answer that one.
I think we would all be able to best answer that. That's a really interesting question. And this is going to sound a little bit blasphemous, but the Environmental Protection Agency has responsibility for surface water treatment and for groundwater. And when the laws and rules were established, they kind of forgot on-site wastewater treatment systems. EPA can handle, address, whatever the word is, on-site systems through the Underground Injection Control Program. They can handle it through watershed programs. But when it comes down to really regulating on-site systems, EPA has some limitations. So what can EPA do? I think one of the things EPA can do is make sure that they continue to reach out to the state health agencies, to SORA, to all of the people that are involved in regulation, siting, sizing, design, installation, operation, management of on-site systems. And again, I'm going to say what I said before. There's no one person that knows all of the answers. There's a few people that think they do, but there's no one person that knows all of the answers. And the problem with people who know all of the answers is they never question anything. So continue to question, and that's what I encourage the agency to do, is to continue to question what we know and what is the state of our science, what gaps do we need to fill. EPA doesn't know that, but the local researchers, people at the state universities, the people at the local health departments are the ones that know the kinds of questions that we need to be asking. That's my answer, Don. I don't know if that satisfies your question or not, but there's roles for all professionals, and we've got to recognize and honor and value those roles.
Yeah, this is Mary. I'd like to join in too on this one, and maybe follow up with Don later, because this is a big question, and I'd love to really have a chance to think about it. I'm glad I've been involved with the MOU partner work that has been going on, as well as the Septic Smart Week, and the funding initiatives that have been happening, trying to build a database so that any town or any state could, resident could look and try to find who provides what kind of funding for on-site fixes, whether it's individual or maybe a small system. I know that when we had our last MOU partner meeting, there was, we were talking about small towns, and a small town is less than 10,000 population. And I looked up, when I heard that, I looked up, and I believe there's either 2 or 3 towns in Vermont that qualify as a small town. And maybe there's a new category of tiny towns that needs to happen, so that we really scale down from, what is a big SRF, machine that has these, large what they call cross-cutters, where there's a lot of additional bureaucratic requirements that are added for, typically a very large, complex system, are still being tried to be imposed onto these very small systems. So if there's a way to scale up on the bureaucratic requirements as well as the funding, that I think that would be a really big help for us. I know that there's a green infrastructure, and I don't know why decentralized wastewater kind of ended up not really fitting into that role anymore. It seems like the green infrastructure stormwater, where they have stormwater infiltration, has co-opted that term, but really whatever is happening on the green infrastructure side could happen on our side too, because really we're both dealing with wanting some separation in soils. You're looking at permeability for how fast water will move through it, and for protecting drinking water sources. So I think there's something more to be done there. So those are my two main comments. Thanks.
Jim, do you have anything to add to that?
No, not on this one.
Okay, so we'll move on to the next question from Lorna. She asked, does any of the presenters have a list of minimum wastewater sampling parameters other than pH and temperature for high strength and or industrial process wastewater?
I'll try addressing that one. This is Jim, because I've worked in that area quite a bit. On high-strength wastewater, I think if you're referring to high strength as generated from a food restaurant or something like that, the general parameters that are used in the industry are measuring the effluent, BOD or TSS that are coming out of the treatment system. You're generally trying to reduce the concentration of that down to a level that your state defines as residential wastewater, and then it can go into a typical drain field. On industrial wastewater, I don't know of any state that allows an industrial wastewater to go into a soil dispersion system, but on industrial wastewater, there's a priority pollutants that should be monitoring, and that would be the extent of what I think you would probably be looking for on that. And I hope that addresses your question.
May I add to that?
Yes.
Go ahead.
Lorna, thank you. That's a great question. And you know me reasonably well. For years and years and years, we've talked about process monitoring and product or performance monitoring. And I think it's really important that we keep in mind that we can look at a BOD measurement by the time I get it is 5 days old. So it really doesn't help me manage my system. But if I'm measuring pH real time, and I'm measuring things like DO, dissolved oxygen, or I'm measuring mixed liquor levels, things that I can measure on real time, those can help me manage my system right now. Looking at indicators like suspended solids or BOD give me a history of how my system is performing. And I think both of those are important. Both the performance indicators and the process indicators are important as we look at infrastructure and sustainability of infrastructure.
Yeah, this is Mary. So on the high-strength wastewater, like Jim said, the BOD, TSS are the two standard tests for like a sewage treatment system effluent. There's also dissolved oxygen and COD that could be helpful, especially for like a non-domestic wastewater, where you might think that there's some kind of a chemical processing that might be throwing off the bugs in the system. There's FOG too, the fats, oils, and grease. that can come into place, especially in like restaurant situations. And then whether you have to do some kind of, total nitrogen, you may be able to do something with the nitrogen series to see how if it's converting, from like ammonia to nitrates to then be able to be denitrified.
May I add to that?
Yeah. Yep.
And if your high-strength waste treatment system is designed for some level of nitrogen removal in addition to removal of organic.
I'm sorry, Bob. There's just some music.
I thought I was supposed to sing, and somebody had my musical accompaniment. That's my humor. Now I forgot what I was going to say. If your system is designed for removal of organics and for removal of nutrients, nitrogen in particular, and we've got to look at denitrification, please look at the alkalinity level in the incoming water, because alkalinity is critical in our denitrification processes. And as far as COD is concerned, I don't work for a regulatory agency, so I can say anything I want. I can get a COD value in 4 hours. It takes me 5 days to get a BOG reading. Please, people, look more at these indicators that give you a response time that you can incorporate back into the operation of your system. Thank you.
All right. Thanks, Bob. Next, we have 2 questions. The first of the 2 from Kevin White are, can you address management models for rural communities where the number of ratepayers are low?
This is Jim, and I can address that from some of the things NARA has been working on. On the small community systems, one of the major funding sources for these small community systems is the USDA Rural Development Loans and Grants Program. NARA in the past sessions has been working with USDA specifically on this problem. One of the major accomplishments last year was that we got USDA to look at the population equivalent a little bit differently. When you're talking of a small rural community where the tax base in that small rural community is not able to put in even an on-site wastewater systems, what we got them to do is consider that you're going to have to expand where your management district is. One of the things that USDA grants and programs requires is that there be a management entity. Someone has to manage that. That management entity doesn't just need to be that small community. If we think about it and increase that management entity, maybe instead of a small community, to a county base. In other words, the management entity for its rate base would not only be operating the small wastewater treatment system, hopefully an on-site wastewater treatment system for that small community, but could be looking to maintain the septic tanks throughout that county. In other words, the sell on this to the county basis would be to the rural providers there. In other words, if you're a farmer in that rural community and you want to help save your city, save your grocery store, save your gas station in that small community, would you be willing to go on a rate base with everybody else and have your septic system maintained by the management entity that's also managing that small rural community, so that you can expand your base to more ratepayers to be able to substantiate that small community system, and at the same time manage the wastewater systems throughout the county by managing the septic systems for these homeowners. In other words, roll it into a bigger picture so that it does have the financial viability that you could possibly be looking for. And I'll pass it on to Bob and Mary for additional comments.
Would you like to go? Well, if you're not, I will.
Okay, go for it, Bob.
Thanks. There's, Kevin, that's a great question, and that's another 2-hour-long webinar. We have the management guidelines that we developed in the 2003-2004 timeframe, and the handbook, the management handbook that came out from EPA. And Joyce Hudson did a wonderful job on that. Or Joyce and her team did a wonderful job on that. The first question is, do you want to be public or private? You could be a public management entity or a private management entity or a hybrid, a public-private partnership. When you start looking at the options that are available, I could be a commercial utility provider, and I could partner with a local county, a local health department, and say, I am willing to provide a service for, and you specify any mechanical treatment and soil distribution system or any septic tank and soil distribution system. So I can define my level of service based on the kind of systems that we're using. They could be an extension of county government. They could be an extension of city government. They could be done as part of a lake management association. There's any number of entities that could be employed to provide some level of management service. I could go on for 2 hours, and you really don't want me to do that. But, Zach, it would be another great opportunity.
Yeah, this is Mary. I agree with you, Bob, that it's a big topic and an important one. And there are going to be a lot of solutions, hopefully, to this. I know that RCAP Solutions has recently received an award from EPA, I believe, on doing some work towards like a regionalization structure to try to develop what that might look like for management of systems. So I think that's a great idea, because a state like Vermont, we have counties, but we have no county government. So really, the towns are either on their own, or we have regional planning commissions, and that's where we're focusing on that. You know, there could be a role for them to help setting up the rates and the structure and the system for managing it, the asset management, the capacity development part, and then they can contract out an operator, you know, for actually doing the maintenance and operation of the system itself. We were just talking with that town, Westford, that I had mentioned earlier, about, you know, where else, you know, could they create funding, and they were mentioning what's called a TIF district. It's a tax increment financing district that towns have a chance to do. That could be one way to create new revenue for it. The idea that was brought up about being able to manage all of the systems in the town. You know, can you put part of the money for construction of a system on a bond vote that goes to the whole town, and give that what they get out of it is that they're able to use and have a vibrant village and all the town services that are probably connected to it, and the store and post office and all that. But they may have their own system that could then be checked. The septic tank could be checked and pumped as part of a fee is rolled into it, so that they're also managing that system on their own property. So there are ways like that can help, but then the idea is that then the user fees would be more connected to the actual maintenance or the management part, but not so, and also part that the construction would be paid by everybody in town.
All right, the next question is also from Kevin White about septic handling options. He wants to know if you all have any options for handling septic, as many municipal POTWs no longer accept it.
This is Jim Bell. Yeah, go ahead, Bob. I'll go in a second.
No, go ahead, please.
Well, what I was going to tell them, what I recommend, good question, too. The NAWRA conference is in Loveland, Colorado. I don't remember the dates in October. You can get with me to get those dates. There will be an entire session at that conference on this topic. It's being put on by NOT, which is a MOU partner, and will address how someone can design their own septage treatment and dispersal in system because this is a major issue throughout the country, and we are addressing it at the NAWRA conference in 2019. Okay, Bob.
Kevin, it's a really good question, because as wastewater, as POTWs get closer and closer to capacity, they're looking for less or lower and lower levels of imported material, because they've got to handle the BOD loads for which way they were originally permitted. So it's a real challenge, because many, many pumpers have been going to the municipality for 30 years or 40 years, and options are somewhat limited as they get closer to capacity. Our North Carolina rules allow us to land apply septage and grease trap waste. I'd be more than happy to send you a copy of those if anybody wants them. If they get back to Zach, I'll be happy to send you a copy of our rules. We have rules for land application. Those are also addressed in the 40 CFR 503 rule on municipal sludge management. Our rules do mimic those. We also have facilities that are dewatering septage and grease trap waste and composting it, and then selling the composted product. So these are really smart people. They're charging for products coming in to the facility, and then they're charging for compost leaving the facility. Some of them are located close to municipalities, and the liquid from the septage dewatering could go back to the POTW as an industrial waste. In other cases, we're land applying that leachate on site, and then the septage compost is hauled off. It's a Class A product, or it's in the 503 rule. It's both a PFRP, a process to further reduce pathogens, which is the highest level of pathogen reduction in the 503 rule, and it meets all the VAR, the vector attraction reduction requirements, so that it can be reused and recycled anywhere. And because most of this is not industrial, the regulated metal levels are extremely low, so you meet the table. If I'm talking quick, and I apologize, but we meet all of the regulated metal levels that are in the table 3 of the 503 rule, so there's no restriction on use. Yes, there are lots of options, and I'd be happy to talk with you or discuss those with you offline.
All right. Mary, do you have anything to add to that?
No, not really. Those sludge dewatering facilities, I think, maybe are the way of the future.
Okay. So the next question is what impact is climate change having on on-site wastewater?
This is Jim Bell. There have been studies on that. I know up in Rhode Island, Bob, help me, Dr. has
George
been doing
Loomis and Terry Gold.
George Loomis, yeah. Dr. George Loomis has been done some work on that. Really, one of the things that this has kind of been a general observation, climate change has had an effect of causing flooding, causing fires, all this type of stuff. And one of the things I found interesting in all these catastrophic event type areas, like right now in Kansas, Missouri, we're going through the flooding aspect, is that the infrastructure that comes back online the quickest seems to be the on-site wastewater industry. In other words, of any infrastructure that recovers most rapidly from an event caused by climate change, you know, flooding, forest fires, that it seems to be the on-site wastewater industry. And that's just a general comment. I'll let others join in after that.
Mary, do you have anything you want to say?
Well, I guess, thinking about this, that it seems like we're getting a lot stronger kind of microstorms that will be impacting groundwater levels. And, you know, if permitting is based on a 3-foot separation between the bottom of your leach field to that seasonal water table, that may be rising over time, and it could impact the system at some point, especially maybe on the systems that don't have 3 feet to the water table, but have something much less. And I'm wondering if the signs of the water table, you would see it in the soils by that, if that actual seasonal rise would change the redoxymorphic features in the soil. They call them modeling. It's a coloration that you can see that would indicate that it is at a higher level. There are a lot of monitoring wells on a number of sites. It would be interesting if someone could take some of that data over the years and take a look at it and see if they see any changes in it. That's all I have.
This is Bob Rubin. And I think it's important to distinguish between sort of two elements of changing climate. One is the catastrophic impact. What's going to happen when we have increased rain events and higher intensity rain events and more flooding and coastal damage. If there are wells that are installed and the cap of the well gets damaged, or the wellhead protection structure is damaged, there's all of those pollutants that can get into shallow groundwater. So those catastrophic, that word, catastrophic events, and how we're going to deal with those. Then the other is how are we going to deal with the chronic, the long-term events? If the water level in eastern North Carolina and the coast of eastern North Carolina rises 6 inches continuously, that is going to have an impact on the shallow water tables, just as Mary was saying a minute ago. And we allow separation distances in some cases up to or down to 12 inches between the zone of application and seasonal water table. Well, if the water table rises 6 inches, what is that going to do in these shallow water tables where the separation is already 12 inches? So it's a real challenge, and it's one I don't think we have obviously thought about. I don't think we've come up with a lot of solutions. And again, Zach, that's the second 2-hour workshop that you can do, webinar that you can do.
All right. The last question we have here is from Mark Elliott, and he's asking, for advanced on-site systems with surface discharge, are you aware of the various state-level approaches to permitting / testing those discharges, or a resource that you can refer him to? For example, much of Louisiana has high water tables that prevent conventional septic systems from working. Other areas have shrink swell clays.
We have in North Carolina, go ahead.
Go ahead, Bob.
We have in North Carolina a state general permit program. The state, it's NC 000555. And it is coverage under a general permit for systems that cannot meet site and soil criteria for a soil-based system. There are several states that have general permits for dealing with on-site systems. Louisiana used to have a general permit, but they didn't renew it, I don't know how many years ago, and they lost their state general permit. Iowa has a state general permit, and in that general permit, the local health department goes out, does an evaluation, or at least they used to. I assume that permit is still in effect. This local health department goes out. If the site doesn't meet local criteria, the health department will ask the owner, do you want us to apply for coverage under the state general permit for you? Then the state will issue that coverage to that homeowner, and they can do any number of systems that meet the criteria for discharge into receiving environments. State general permits are a great tool. The other option is individual permits, and those can be a little bit more onerous, but yeah, they do exist out there. I'm sorry, Jim, you were going to say something.
Yeah, I agree with everything Bob said. I was going to give you additional states that have state general permits that I'm aware of. Illinois, Iowa, and Arkansas also have state general direct discharge permits. So yes, it can be done. It's something the state organization needs to, well, the health department needs to work with the EPA group in the state to get an MPDS permit for a general permit for discharge. It can be done. It has to be set up first.
Yeah, and if I could add about Pennsylvania, I've been involved with a few system constructions that had a surface discharge, and they, have, advanced treatment requirements plus disinfection before it is discharged, and they have monitoring requirements on that. If you want, I could research and get you a link to their regulations about their systems. There's also other states that require or allow for surface discharge. We don't in the state of Vermont, but I do remember in Illinois talking with one of the regulators several years ago where they were thinking that, here's two counties, one side by side, and one is still able to do some kind of soil-based treatment system permitting. Well, the other one is feeling like, no, we have karst soils and we're not going to be able to put anything in it, so we're going to go with a surface discharge. So there may be that, if you, nowadays, you can have as little as 6 or 12 inches of unsaturated permeable soil and be able to do an on-site wastewater treatment system that will treat that wastewater to a high degree. If you're going to that narrow a limit, you'd probably have to have the advanced treatment in front of it. But really, 6 to 12 inches of soils have pretty much proven that will treat wastewater.
All right. Well, we are out of questions, and it's just about 3 o'clock, so we're just about time. I'll let you all off 4 minutes early. I just wanted to thank you all again.
Zach.
See a question?
Yeah, from Peter Mitchell.
Oh, okay. Sorry, I had to scroll up. Yes, so Peter Mitchell says, I have read in some cases that redox features modeling can form in a matter of a few weeks. Not sure on glaying formation. I see Bob responded to that, but if any of you have anything to add to that, to Bob's response.
Yes, redox features will form in a very, very short period of time if the conditions are right. And remember that the formation of these redox features, depositions or depletions or all of those are biological processes, and they can take time, and they do need sources of nutrient and sources of food and all of that stuff. But yes, they can form in a very, very short period of time. There was some work done on that here at NC State, 20 years ago by Dennis Osborne, maybe more than. Everything to me is 20 years ago, and it's sometimes longer. But yes, they do form in a short time if conditions are right.
And then they don't really disappear. So that's
Correct.
why historically you can't really tell if that, seasonal water table still exists today or it did 10,000 years ago. The assumption is it is today.
And getting back to the question about the climate change and all of that, and that's why some long-term monitoring of questionable sites through a rainy season to determine the depth to water table, it could be really important as a tool in managing or designing on-site systems.
All right, is there anything else that any of our speakers would like to add before we conclude? Or any final questions?
I'd just like to thank everybody. Thank you all.
All right, and thank you, Bob, and Mary, and Jim. We really appreciate the time you took out of your busy schedule to plan this webinar. I know it took a lot of conference calls and a lot of iterations of the PowerPoint to get it to where it was today, so we really appreciate all your effort. As a reminder, this webinar is being recorded and will be available on the EPA webpage soon, so you can all share it with those who might not have been able to attend